Hey everyone, welcome back to Pine Hollow Auto Diagnostics. Today we're at a shop here in State College. We're working on a 2007 Kia Spectra, and the customer complaint is crank no start. So here it is. Let's verify the customer complaint. Ooh, stick shift, sweet. 166,000 miles. I got the key. Key on. I don't see a check engine light, so let's try it. Okay, definitely a crank no start. And the shop here, they said we check for spark, no spark, check for fuel, no fuel. I don't see a check engine light, and they said that with their scanner they couldn't talk to it. Okay, so let's plug in our scanner to verify. Probably have no communication, and then what do? Go right for the PCM, powers and grounds. All right, let's do key on. Got the scanner loaded up with the proper vehicle, engine, codes, no codes. Wow. All right, next step, let's pull up a wiring diagram for the PCM and see what we're missing. All right. Here is the non-OE color diagram. I chose to use that because the OE diagrams, they're just like page by page, and you can see there's battery power, but it doesn't show all the powers and grounds on one page. So let's go to this one. Right here on the PCM, we see, let's see, ground, ignition power, another ground, main relay on power, another ground, battery power. So the first 6 pins are all powers and grounds. And where does this PCM live? Let's see here. It says ECM, integral to instrument panel junction box. So it's inside. Let's look under the dash. All right, here we are. Let's see, we don't need this guy for now. And here's our PCM, I think. Yes, one big connector. And let's see here. What is up with this? Why does it look like it's unplugged? See, this is one of those slide connectors, and you can see where the dust is, that line. For some reason it was unplugged, so you know what? Let's start by plugging in the PCM. Like that. Let's see what happens. This car starts. Hey look, our check engine light's back. Alright, let's see. We got fuel pump. Unbelievable. Now, it's shaking. It doesn't really run that well, but hey, it actually freaking runs. I don't know. So, okay, why was the PCM unplugged? The shop owner told me that the customer was moving their car in a driveway and then parked it, and then it didn't start. That was it. So let's come up with a hypothesis. I mean, it's a stick shift, and that plug was kind of next to the clutch pedal. I mean, there's no reason it should be unplugged. But if you move the clutch pedal, maybe his foot hook this. I mean, that's pretty easy to unplug right there. It's interesting. Well, oh, it's doing a spark check. No wonder it's misfiring. Let's fix that. Let's see, we don't need this guy anymore. Plug that back in. Sweet. There we go. See if we have any codes stored. System voltage, cam crank correlation. Okay, I'm gonna delete these. Yes. Continue. Cycle the car. Guys, I'm sorry, this is not Staten Island. I've never seen just the accidentally unplugged PCM before, so, but hey, super quick and easy diag. Thought process was the same. It led us right to the same direction, and that's it. So sometimes you get lucky. They don't all have to be hard, and these are kind of the money makers, and you still get 1 hour of diag. It doesn't matter, got the car running. But interesting. So cam crank correlation bank 1 sensor A. I'm wondering why it's not setting the check engine light. So we might not be done just yet. Alright, I took the car for a spin. It drives. However, check engine light is back on, and this P0016 code is definitely present. So, you know, diagnose the crank no start. Now let's diagnose the check engine light. Again, it's going to be an additional charge. It's another issue, so the shop, you know, okayed it. And let's dive right in here. Troubleshooter. Engine code tips P0016. Alright, so this has continuously variable valve timing installed to the chain sprocket on the exhaust camshaft. There's no variation in valve timing of the exhaust cam because the exhaust camshaft is driven by a timing belt. I believe that's a misprint. One of those should be intake. You know, one of them is fixed and the other one varies. Timing of the intake cam is varied by the relative operation of the CVVT vane to the housing. So I believe it has variable valve timing on the intake cam. Okay? So that should be intake. Now, the CVT controller regulates the intake camshaft using oil pressure. Yep. Relative position between camshaft and crankshaft becomes optimal. Engine torque improves, blah, blah. This diagnosis checks the camshaft position plausibility, whether the expected range plus some margin is not violated and might be caused by a wrong engine repair or timing belt misalignment. It's set when the actual camshaft position is too much retarded or advanced than the full retard position or full advanced position. Continue the adjustment in such case. That's a could damage the pistons and valves. Okay. So, possible causes: camshaft, crankshaft, tone wheel. For some reason, it doesn't say installation of a timing belt, and this car just had its timing belt recently replaced. Interesting. Check camshaft signal switching. Switching out of 108 to 142 in full retard or 70 to 140 during VVT control. You can shortcut right to the data groups. Alright, let's see, custom. Let's see what we have here. Deselect all. Synchronizing status, not sure what that is. And I'll just scroll through here and pick out the right PIDs. Alright, so I picked out all the CVVT data PIDs, and check this out. Hey, we're in limp home mode. So retard. It's at 124 degrees. Now, is that good or bad? We don't know. Let's see, rev it up a little bit. I think it's just fixed there right now, and that's what it is. So I'm driving this thing. If you floor it, you can hear kind of like something dinging or rattling. And the power really, you know, I think it should be a little bit peppier than this. Can I floor it? There's no real high-end pull. It's kind of lazy. So definitely have an issue. So we got the Pico scope set up to do a cam crank correlation. And how awesome is this? Hyundai actually provides known good scope captures of cam and crank. This is beautiful. I wish all manufacturers would do this. It would make our jobs so much easier and more efficient if we didn't have to hunt for this information. So right in the description for the P0016, we have known good pictures of the cam and the crank. So it even shows you, with repetition, there's the sync notch, and zooming in, the falling edge is 3 notches before the sync. So the square wave signal should be smooth and without any distortion. The CMPS falling or rising edges coincided with the 3rd to 5th tooth of the CKP from one longer signal missing tooth. Okay, so if we go by time, the cam is advanced with regard to that sync notch. Should be pretty straightforward. Now for the pins that we're connected to, it's the middle pin. It's 3-wire Hall effect sensors. The crank sensor lives right down here. We're on the white wire in the middle, and cam sensor, green and orange wire, also the middle wire. So 2 channels. Let's fire up the Pico and see what we have. And I disconnected the oil control solenoid. So this is the exhaust camshaft driven by the timing belt right here, and on this side has the VVT sprocket, and there's a chain that drives the intake cam. That's the Hyundai design. So exhaust camshaft is fixed timing, and then this thing rotates and basically phases the intake. Interesting design. So 2 channels, plus or minus 20 volts. Let's put let's see, that's crankshaft is the blue trace. That's camshaft. I don't know, let's fire it up and see if we have signals. Okay. Let's see, can we get something better on the crank here? Here we go. Awesome. I like it. We'll just let it roll. Pause it. Zoom in. There we go. Pico, I love you. And what do we see? Look at that. That's way advanced, right? That's the cam. It's occurring. 1, 2, 3, 4, 5, 6, 7, 8, 9 teeth before that sync notch, and our spec was third to 5th tooth. So we're like way over here. So we can tell them, hey, the timing belt in this case is definitely offset. All right, just the final shot with some degree cursors. How far off are we, and which way is it? Well, by spec, if we're 1, 2, 3, 4 notches from the sync, that's going to be about 45 degrees. Now we are 1, 2, 3, 4, 5, 6, 7, 8, 9, almost 10 notches ahead of the sync notch, and that would be about 65 degrees advanced. Now again, we can look at a camshaft sprocket or the crankshaft sprocket and see how many teeth that is. 65 degrees on the crank is about 1/6 of the entire sprocket. So, you know, probably 2 teeth off. That would be my best guess. So actually, with the cursors, you have to be careful. If you're doing 1 sync notch on the crank, you have to make sure that this number down here is 360. Okay, and now our degree measurements should make a little more sense. So let's see again here. From here, 1, 2, 3, 4, we should be about 21 degrees, and we're advanced by about 30 degrees. Okay? 30 degrees on the crank would be about 1/10 of the rotation. Again, 1 or 2 teeth. So, hope you guys enjoyed that case study, and stay tuned for more. Catch you next time. Bye-bye.